Here we go with part 2 now. We're solving quadratics. And so I'm going to start by solving by factoring. So when I look at factoring this out, I'm looking for factors of a times c. So if I look at a times c, that gives me negative 18. And I'm looking for factors that will add up to give me this middle term, positive 7. And so if I look at that list, I'm going to come up with positive 9 and negative 2. Add up to be 7 and multiply to be negative 18. That's going to be our best choice. So I'm going to split that middle term so that I use those two numbers. 6x squared plus 9x minus 2x minus 3. And then I'm going to notice that there's some common factors between the first two terms, and there's some common factors between the next two terms. So the first two are both divisible by 3x, and I'm left with 2x plus 3. And the next two are just both negative, so negative 1 times 2x plus 3. And so when it factors, it's always going to produce the same factor in those parentheses. So 2x plus 3 is a factor, and then the remaining factors are going to be the 3x minus the 1, where I noticed that this was common to be multiplied by 3x and minus 1. And so those show up there. And then that leaves me with my final result. What would make 2x plus 3 equal 0? X would have to be negative 3/2, or here, x would have to be positive 1/3. Here we want to solve by quadratic formula. So we're going to use our a, b, and c values. Here we have a is 5, b is negative 3, c is positive 8. And so we're going to say x is going to be the opposite of b plus or minus the square root of b squared minus 4 times a times c. And I note right away that I'm probably going to get an imaginary number because I'm taking 9 and minus this large value all over 2a. So when I simplify this, I'm going to get x equals positive 3 plus or minus the square root of 9 minus 20 times 8 would be 160 over 10. This becomes, underneath the radical, negative 151. So because that is a negative, I'm going to simplify it finally to be 3 plus or minus I times radical 151. These are imaginary values. Then we move to our last one here, and we're solving a quadratic inequality. So that means our answers are going to be intervals, parts of the number line. And so the first thing I want to do is I want to take this and get it so that I have 0 on one side. And so I'm going to isolate subtracting 7x from both sides. And this greater than 0 tells me I'm looking for where the function is going to be positive, where the parabola is going to be positive. It's also positive over here. So that tells me this, if I'm picturing in my mind a parabola that opens up. And if that parabola crosses the axis, if there's two real solutions, the positive parts are going to be from negative infinity up to something and something to infinity. That's kind of the mental picture that I'm forming. So we want to go ahead and factor this, and we notice that, again, negative 18 and 7, we saw this same two numbers in the previous one. We're going to factor into x minus 9 and x plus 2. Now at this point, I'm only concerned with where it is equal to 0. There's many people who are making the mistake of keeping an inequality here. We are not trying to find an inequality here. We're trying to find the places where it equals 0. 9 and negative 2. So those two values are these 2 points. And so what that does is that tells us that our solution is going to be negative infinity to negative 2. And we'll use a bracket because it says it can be equal to 0. And 9 to infinity. All right? And so that's our final answer.